English, unfortunately. So thanks a lot, first of all, to Cittadini per l'Aria for this invitation to present our work. As you said, I work at the European Environment Agency. I work as an air quality expert. So basically, we work with the data provided by our member countries, and we analyze the situation of air quality. We produce several reports, several indicators. I will introduce a bit more the agency in the presentation. So if I think we can start straight ahead. I will stop the video, so I'm sure the connection is okay. I will come back. You will see me again in the question sessions.
Okay.
So I stop the video and I will start sharing my screen. Sorry. So can you confirm you see my screen?
Yes, it's good. We see it.
But you just see my presentation. You don't, because I can see also all of you like in the.
We can only see the presentation. We see only the presentation.
But it's strange because, sorry. Something prevents me to put it in presentation mode.
Yeah, actually, it's a little bit smaller than ordinary. Maybe, yeah.
But let me try again. Now?
Yes, now it's perfect. Thank you.
Okay, great. Okay. So, as I said, well, as Elisabetta said, I will present you with the results of the air quality in Europe report 2019, and I will focus on Italy. And afterwards, I will present you where to find some of the air quality and air pollution data that I have been used for this presentation. So first of all, just a reminder of who we are. The European Environment Agency is a European Union agency whose task is to provide relevant, reliable, targeted, and timely information to policymakers and the public, with the aim of helping to achieve significant and measurable improvements in Europe's environment and to support sustainable development. The agency was created back in the 90s together with the European Environment Information and Observation Network, which is a partnership network with the countries consisting of more than 1,800 experts from all over the member countries of the European Environment Agency. You can see here in the map all these countries. So you see in green the member countries, which are the European Union countries, plus 5 other: Iceland, Turkey, Liechtenstein, Switzerland, and Norway. And we have also 6 cooperating countries, which are the countries in the Western Balkans, which you can see here in yellow. And our main task is to collect data and information, and we then create and distribute knowledge on both the environment and climate change. So here you have an outline of what will be my presentation. I will first introduce briefly what is air pollution, what we understand by air pollution. And then I will focus on the Air Quality in Europe report, presenting some of the results on emission of air pollutants, concentration of air pollutants, how people are exposed to this pollution, and the health effects that this entails. Focusing also on Italy, how Italy shows in comparison with the other countries. And then I will provide some conclusions. We can then start question sessions, and then I will guide you through our webpage to show you where to find the air pollution data we handle. So first of all, a very basic reminder, when we talk about air pollution, we talk about two different things. First of all, we have emissions of air pollutants. Emissions is the release into the atmosphere of air pollutants. And this happens mainly by man-made activities, economic activities, but also from natural sources. So if we think of man-made economic activities, we have industry, we have traffic, we have agriculture. If we think of natural sources, we have volcanoes or forest fires. When these pollutants are released into the atmosphere, they suffer both chemical and physical processes. So they go through chemical transformations and they become new pollutants. They are removed and they are dispersed by the wind, they are removed by the rain. And at the end, what we have is what we call air quality, which is the concentrations of air pollutants that we breathe and that impact our health and the environment. And to act against air pollution, we have to act, or we can act both in the emissions, that is in the amount of pollutants that we release, and also in the concentrations that we are exposed to. And actually, this is what the European legislation has done so far. The air pollution legislation is a very well established legislation in Europe. It's been in place for quite a long time. And first of all, targeting emissions, we have what we call the National Emission Ceilings Directive, which is a legislation trying to set maximum amounts of pollutants per country and per year to be released into the atmosphere. So it addresses these 5 pollutants you can see here: sulfur dioxide, nitrogen oxides, the volatile organic compounds, ammonia, and the fine particles. And this directive sets this amount of this maximum amount of pollutants to be released for 2010 and 2009. That was the old directive, and it was revised like 4 years ago, and it sets new commitments for 2020 and 2030. And on top of that, we have also sectoral legislation that limits the amount of pollutants that can come into the atmosphere from specific sectors. For instance, for transport, we have the Euro standards limiting the amount of nitrogen dioxide or particulate matter that can come into the atmosphere from vehicles. We have the Industrial Emissions Directive setting also limits for specific industries on the pollutants that they can release. We have the Directive on medium combustion plants, and we have also regulations for specific products, as for instance, paints, the amount of solvents that paints can contain. All this information about European legislation can be found in the European Commission webpage. And we have also an international convention, the Convention on Long-Range Transboundary Air Pollution, or Convention of Geneva, that consists of all the European countries, not only the European Union countries, and that also sets this kind of maximum amounts, ceilings in the emissions of certain pollutants from certain activities. So apart from that, we have what we call the air quality, and in this case, we have the air quality directives that set maximum amounts of concentrations for several pollutants. This is what we call the legal standards that cannot be exceeded. So these directives obliges all the member states to assess the air quality in their territory, and for that they have to divide their territory in different zones and agglomerations, and then they have to measure the amount, the concentrations of the air pollutants. This is done basically through monitoring stations, and here you have one picture of one monitoring stations where we measure all these pollutants, and it can also be done with the help of air quality models. Once we have assessed the air quality, in the case when we have exceedances of one of these standards set by the directive, we have to implement plans and measures to improve the air quality, and there where the air quality is okay according to the standards set in the directive, we have to maintain this air quality. And also the directive sets some obligations to inform the public about the whole thing, about the assessment, about the management, about the zones defined for these issues. And the countries have also to inform the European Commission, and this information is done via the European Environment Agency. So this is part of the data that we collect from our member countries. Here you have some examples of these legal standards set by both the Air Quality Directive, you have them on the left, and on the right you have the standards recommended by the World Health Organization to protect health. And you can see that in most cases, the guidelines defined by the World Health Organization are stricter than the legal standards set by the directives. So with all this information, as I said, we create knowledge, we distribute knowledge, and one of our main products to do so is the Air Quality in Europe report. We have issued 9 editions so far. We started in 2011. What we do is to present an overview of the situation in Europe, both in terms of emissions, but mainly in terms of air quality or concentrations of air pollutants. And we also assess the impact of these air quality concentrations on health and on vegetation. So as I said, this is, last year we issued the 9th edition. This year, to celebrate the 10th edition, we will have a special content. We will make a trend analysis of the concentrations in the past 10 years. We will present also how the health impacts have evolved since the beginning of the series of the report. And I have also to say that this is one of our best sellers in terms of distribution, downloaded, and so on. And also in terms of the interest by the media and the journalists. So if we go already in what this report from last year says, we can see that the emissions, that is the amount of pollutants that we release into the atmosphere, have decreased in the last years. Here you have for 6 main pollutants, the amounts per year of each pollutant in comparison with what was emitted in year 2000. So we see that for all the pollutants, the emissions have decreased. We see here for sulfur oxides that what was emitted in 2017 was 23% of that what was emitted in 2000. So that means that there was a reduction of 77%. And this is the pollutant for which emissions have decreased the most. And you have here for ammonia that the emissions have only decreased 9%. And we present also here the gross domestic product, which is an indication of the economic activity to show how there has been a decoupling between the economic activity and the economic growing and the emissions of air pollutants. In any case, if we have a closer look into pollutants or sectors, we see that this decrease, this general decrease, is not the same from all sectors. And here on the left, you have the commercial, institutional, and household sector, mainly residential heating. So the burning of fuels to heat our houses and our shops and our buildings. And you see here that the decrease is not as big as in general. For SOx, we had, for instance, 77%, and here we only have about 40-something. And we can also see that, for instance, for agriculture, the emissions in the last years considered have increased slightly. So this is an indication that even is overall the emissions have decreased, it's not the same for all sectors. It's also important to see from which sectors the pollutants come from. And here you have, for the same 6 main pollutants, distributed around 9 sectors, which are the main contributors. And we can see that depending on the pollutant, we have a main contributor. This is the situation for the EU member states, the EU 28 as a whole. This situation can differ country by country, but we see in general that for sulfur oxides, the main sector contributing to its emission is energy production and distribution. For primary particulate matter, we have the commercial, institutional, and households, that is the residential heating. For nitrogen oxides, we have traffic. For the volatile organic compounds, we have industrial processes and product use, mainly the use of solvent in industrial processes. And for agriculture, we have, and for ammonia, we have agriculture. So we see here that each sector, let's say, has a main pollutant, is the main emitter of one pollutant. As I said, this situation can differ if we have a look country by country, and here we have the same situation for Italy in 2017. So at national level, we can see that the sectors are the main contributors to the same pollutants as in the European situation. But here we have that, for instance, for SOx, for sulfur oxides, the situation in Italy is that non-road transport contributes more than in the European case. We have that for the particulate matter, the residential heating is even a bigger contributor than in the European aggregation. And also for the nitrogen oxides, transport, both road and non-road transport, is also more important than in the European case. So how has this decrease in the emissions translated in when it comes to the concentrations, when it comes to the pollutants that we breathe and that affect our health? I will present now the situation for several of these pollutants. And here I present a map to the left when you can see dots. Each dot represents one of these monitoring stations. And colors red or dark red represent stations where the legal standards have been exceeded. Here you have the situation in relation to the daily limit value for PM10. And you can see that there are some red dots all over Europe, but we have mainly concentration in Eastern Europe, Turkey, and Italy, especially in Northern Italy, the Po Valley. So if we go to the detail, we have 17 member states reporting exceedances of this daily limit value, and 6 other reporting countries, which, I mean, these other reporting countries are either the EEA member countries, which are not EU member states, or the cooperating countries. And here in this graph, you have for each country a line which represents the minimum concentration measured at any station, the maximum concentration measured at any station, the average of all the stations, and then you have in this box, the lower part represents the percentile 25. That means that 25% of the stations have values below this lower box. And we have also that 25% of the stations have values above the upper mark of the box. So when it comes to Italy, we can see here, the red line represents also the limit value, the European limit value. So you can see here, Italy, that more or less 50% of the stations have concentrations above the daily limit value. And in most of the cases, not for Italy, but also not only for Italy, but for the rest of Europe, this situation happens at urban stations. That means that stations located in cities. that indicates that the exceedance of particulate matter is mainly an urban issue. We have a look now to the PM 2.5, the fine particles. We see that when it comes to concentrations above the limit value, we can see more or less the same areas. The exceedances are not so, I mean, there are not so many as for the case of PM10, but we can see that they happen mainly in the same areas, Eastern Europe and the Po Valley. If we go to the situation by country, we see that 7 member states have reported exceedances of this of the annual limit value for PM 2.5, Italy being one of them. And you can see here also, I mean, again, we have the limit value as a red line, and we have also a dotted red line, which is the World Health Organization air quality guidelines. And if we just focus on this, we can see that only 3 countries, which are Finland, Estonia, and Norway, have reported all the stations below this this recommendation by the World Health Organization. Moving now to ozone. Ozone is a secondary pollutant. That means that it's not released directly into the atmosphere, but that is formed in the atmosphere from other gases, mainly nitrogen oxides and volatile organic compounds. And to form this secondary pollutant, we need sunlight and we need heat. So we can see here that the higher concentrations happen in South Europe and mainly around the Mediterranean, because it's when we have more sunlight to produce this pollutant. And we see that 17 member states have reported concentrations above the legal standards, with Italy again being one of them, actually one of the countries with the highest values of this pollutant. And as I said, we have this gradient from northern to south, with the highest concentrations in the south. Now for NO2, nitrogen dioxide, here we see a different distribution of the exceedances. We see a lot of red dots all around Europe, and these red dots correspond mainly to the main cities, to the biggest cities where we have more traffic. Nitrogen dioxide is emitted mainly by vehicles. And we have, in this case, 16 member states reporting exceedances. Again, Italy is one of these countries. And as I said, this is a traffic issue, and most of the exceedances happen at stations close to roads and established there to measure the concentration coming from traffic. Then we have another pollutant, which is benzoapyrene. Benzoapyrene is a carcinogenic pollutant and is emitted mainly from the combustion of coal and wood for domestic heating. And in this case, we see that the highest concentrations happen in Eastern Europe, which is the zone or the region where the use of this coal and wood is more common when it comes to residential heating. Still, we can see that in Italy we have some exceedances of the legal standards, and mainly again in the northern part. And again here we have mainly the exceedances in urban areas, indicating again an urban issue linked, as I said, to this residential heating. Now I present here the situation for 2 pollutants related also to traffic, which is carbon monoxide and benzene. And in this case, we have very few exceedances. Yeah. So this is one of the success stories we like to also tell. I mean, as I said at the beginning, the decrease in the emissions of the pollutants have in some cases led to no exceedances of the legal standards for some pollutants, and these 2 pollutants are a very good example. Here we have the situation for the heavy metals. And on the left, you have a graph with a similar situation as the one I presented before for the 6 main pollutants. So you have, again, the emissions at EU level of these 5 main metals: arsenic, cadmium, mercury, nickel, and lead. And we can see also that the emissions of these metals have decreased in all cases, being lead the one with the highest decrease, and being arsenium the one with the lowest decrease. And when it comes to heavy metals that are emitted mainly by industrial activities, in the case of Italy, we see that all the stations are below the target value, except one station for cadmium, which is located in Sardinia. And this is a suburban background station, probably close to an industrial facility exceeding this target value. So why we are worried about all these concentrations? As I said, in most of the cases, some of the highest concentrations happen in urban areas, which is where most of the European population live. So here we present the situation of all the European Union urban population in terms of the legal standards defined by the European Directive or the World Health Organization. And here we present the percentage of this urban population living in areas where these standards have been exceeded. So on the left, we see that around 20% of the population lives in an area where one of the European legal standards have been exceeded. But if we look into the right, we see that when it comes to the World Health Organization recommendations that I said at the beginning are stricter, we have a much more percentage of population living above these exceedances, with, for instance, Ozone, almost all the population living in areas where the recommendations for this pollutant by the World Health Organization are exceeded. And if we have a look to the specific case of Italy, we see that in general the values are higher than for the European as a whole. So this exposure to high concentrations of air pollutants entail also health risks, and we estimate. We started like 6 years ago, I think, in this air quality report, we estimate this impact of the air pollutants on the health, and we calculate the premature deaths attributed to exposure to 3 pollutants: fine particles, nitrogen dioxide, and ozone. Here you have 2 of the reports that explain the methodology we use. This is the map we use. I mean, this is a map when we take into account the concentrations reported by the countries, the map I showed you before, but we also complement this with other supplementary data as results from models, meteorological values. So we estimate the concentration all above Europe, and then we estimate out of the total deaths that happen in a year in each country, we attribute some of these deaths to the air pollution. And the latest estimations that are presented in the 2019 report for year 2016 show that around 400,000 premature deaths are attributed every year in Europe to exposure to PM. So concretely, if we look at the EU28, we have 374,000 premature deaths attributed to the exposure to PM 2.5. For all the European countries, we have 412,000, and for Italy, we have almost 59,000. We also made an exercise in last year's report when we tried to see what would be the effect of reaching this World Health Organization recommendation of 10 micrograms per cubic meter everywhere in Europe. And we saw that we will avoid at least 30% of these premature deaths, which would mean that we would avoid more than 100,000 premature deaths per year, reaching this recommendation by the World Health Organization. So finally, I present here because sometimes we also forget that air pollution doesn't affect only health, but the environment in general. And I present here a map of ozone in relation to a protection target for vegetation. As it was the case in the other map I showed, we see again that there's a gradient with the highest concentrations around the Mediterranean, because again, this is ozone, so this is this secondary pollutant originating from with the help of sunlight. And we see here that almost 1/5 of the total surface devoted to crops is exposed to levels of ozone that are considered harmful for the vegetation. So to conclude this first part of the presentation, I would like to highlight, as I said, that the emissions of pollutants have decreased in the period considered, 2000-2017. And in most cases, this is due to the implementation of European and national policies to abate these emissions. In any case, we see that it hasn't been the case for all pollutants and for all sectors. We have seen decreases, higher decreases, bigger decreases in some sectors and for some pollutants than for others. And even if this has gone to a decrease in concentrations, we still see exceedances of the legal concentrations for some pollutants, and especially for the World Health Organization recommendations. And this implies that people are still exposed to levels of pollutants that are considered harmful, and this entails all these health impacts I was mentioning in terms of premature death, and also impacts for vegetation and crops. So we need additional measures, and we need additional measures, especially in those sectors where the emissions have decreased the least, as for instance, agriculture, transport, or domestic heating, also because in these cases, the emissions are very close to where people live. These are these urban issues I was mentioning when I was presenting the maps. And we just don't need technological measures to decrease the emissions. We need to think a bit further, and we need a systemic change. I mean, we just don't need to decrease the emissions of vehicles. We have to think further, and we have to review our mobility system, our food system, our energy system. So it's not enough just to have technological improvements. We have to rethink the way we move, the way we feed ourselves, the way we heat our households. And of course, I mean, I didn't mention it before, but air pollution has several levels, several scales, and all these things can only happen, this improvement of the situation can only happen through the cooperation and the coordination at several levels, starting from the international and the European level and ending at the local level. So with this, I finished the first part of the presentation. And
thank you very much, Alberto. We can, if you want, stop the sharing of the screen.
Yeah.
Okay. Nice to see you again.
Yeah. I will take some water, sorry.
Yes, absolutely. It was very, very interesting, especially to see I think for everyone, especially to see the comparison between the countries. So how much of the pollutants are in one country and another one. And Italy seems to be on top of them all. So it's pretty scary.
Yeah.
Good news. So Anna, shall we start with the questions?
Yes, absolutely. I've already seen, if you want, I can translate Juzy's question, or do you want to ask her, Juzy, ask him? No, okay. Because Juzy lives in Sicily, near Syracuse, where they have a huge industrial problem. And she was asking, well, she actually wanted to highlight that in her area, under the law, they have stopped looking for those proxies pollutants that are typical of the industrial areas. And therefore, what is happening is that they reach the crazy situation in which their air quality is considered good, but they do not search for PA and PCB and PCDD and PCDF,
yeah.
and obviously this is very worrisome for citizens. That's my addition.
Yeah, well, I didn't mention all the pollutants that are regulated under the Air Quality Directive. Those that have legal standards are the main ones I was showing, but it's true that there's also the obligation to measure some of these PAHs. And there are also, the specific legislation related to industrial emissions, in some cases also ask the installations to measure these pollutants. So I don't know if there's a specific question or.
No, I think she wanted to highlight.
This issue, yeah.
I don't know whether she was wondering if that was legitimate. She's actually a lawyer herself, so she might have wanted to
highlight this issue.
Okay. Whether they can challenge the failure to monitor. I don't know. Juzy?
Excuse me, I try to speak in English. I want to say that actually, when we look at the parameter of the quality of area, we have not nothing about what the industrial emission are in this country. And I think since 1983, because before this date, we have the DPCM who included this kind of emission. But now, anyway, we have not directive or laws about this. So obviously, when the report about the quality of area became public, we cannot read nothing about this country. Syracuse is the most important CIN. Does it mean CIN? Sito of national importance about bonification area, because we are an ARCA place. ARCA, what does it mean? Is a site with with an elevated risk for the population, for the country at all. So I think why is it possible this question in Italy? This is I think a big question, and I love this kind of question.
Well, I mean, I can only say, yeah, that, I mean, for instance, this benzopyrene is one of the pollutants that are measured as a proxy of the rest of the polycyclic aromatic hydrocarbons. So there's an obligation of measure this when it's above certain limits. Of course, I mean, I don't know the specific situation of, or we cannot, also because, I mean, in the agency, we rely on the data reported by the countries. It's the role of the Commission to check the compliance with the data we provide to them. But as I said at the very beginning, we have this IONET network when we work closely with the countries. And we are not the ones controlling the countries. We are like kind of partners. So of course, there are also some institutions where you can complain, I guess, or if you think that, I mean, not all the things that should be measured are measured, starting from the Italian Ombudsman, the European Ombudsman. You can also, if you know about, I mean, that this is really a problem, you can also make a complaint to the European Union. I mean, if maybe you have already touched all the local or regional institutions or authorities.
Okay, thank you. I do it. Thank you.
Okay, so we can keep going. We can keep going with some other questions. I see that, for example, Enzo asked if there's some data about harbors. So the ships pollution coming from ships. If there's some data.
Well, I mean, we have stations close to the harbors or to the ports. So I mean, as I said also at the beginning, we have to distinguish between what is emissions and what is concentrations. So the emissions from shipping is one thing, and then what we can measure in the monitoring stations close to ports is another thing. But here, what I present, I mean, we don't have a sector for shipping as itself.
Okay, I don't know if Enzo, you would like to tell us more.
Thank you very much. I think it's correct that the monitoring equipments near the port are not so good for detecting the pollution from ships. Thank you very much.
Well, we have we have not only this, we also have the results from modeling. For instance, when we see we can trace the ship routes by the emissions of nitrogen oxides, for instance. Yeah, and we know also that sulfur content in some cases is. So there's like other instruments. We have this ECA, these emission control areas in some seas where control the amount of pollutants in certain fuels. And it's true that, I mean, shipping together with aviation is one of the sectors less regulated so far.
Yeah, it's true. So thank you. And in fact, we have some other question about it. So Alexander asked, how is the tourism industry labeled in the graphs? For example, airlines and cruises.
Well, again, in the emission sector, I mean, inland shipping is included in non-road transport, but international aviation is not included in any of these emission sectors.
Okay. Yes. So I'll pass to the next one from Angelo, and he asked, couldn't ammonia emissions reduce ozone emissions by chemical reduction?
Well, ammonia emissions are mainly an issue because they act as precursors of secondary particulate matter. So ammonia together with nitrate or sulfate creates this secondary particulate matter. When it comes to the reduction of ozone emissions, I mean, I haven't read anything related to this thing of ammonia acting as a counter pollutant for ozone. In any case, as I said, ozone is not emitted, so ozone emissions could reduce ozone concentrations or ozone formation because ozone is not emitted, it's created in the atmosphere through chemical reactions.
Okay, thank you. And then we have some questions that are non-road transport is a small share of total emissions, even in Italy, presumably because shipping emissions are still excluded from budgets.
Yeah, as I said, it's only inland shipping, which is that's what I think. Because I'm not an expert on emissions, but I think in the national emissions inventories, shipping and international aviation are not considered.
Okay, and then there's a subsequent question, which is, will it change anytime soon, inclusion of aviation and maritime shipping?
I know there are some discussions to include them, but as I said, I'm not an emission expert, so I don't know exactly in which state this is. But yeah, I mean, we are aware that these are serious issues. The thing is, I mean, what I understood is seems that who should, I mean, when you are in an international cruise, who should, I mean, to whom you allocate the emissions, to the ship, I mean, to the owner of the ship or the port when it came, the port. So it's like, I think that there was this legal issues on how to attribute the emissions and where and to whom.
Well, the result is terrible, though.
Yeah. So I mean, what we can do is, of course, signal these things, and we can see sometimes through the concentrations we can see this issue.
Yeah, actually, I have a few questions, Alberto. One is, ozone is increasing, isn't it? I mean, kind of. Do you have any reason for that?
What do you mean ozone? Because I mean, the thing is, it seems that annual mean of ozone is increasing, but that the highest peaks are decreasing. So, because I mean, ozone is very complex, and we have several metrics to measure ozone. So it seems in some cases it can be due to hemispheric transport. So in some cases we have ozone coming from Asia and also from America, and this is one of the explanations. We also have the issue of the nitrogen oxide, because I mean, ozone and nitrogen oxides have this very complex chemistry and very complex balance. So sometimes reducing NOx implies an increase of ozone, and this would be maybe something interesting to see with the lockdown measures. The thing is also for ozone, we need like higher, I mean, longer time series. So the period of the lockdown is very short, and also the thing is that it was not the most active period in terms of photochemical activity, but it would be a good example. And yeah, I mean, it's also, when you say it's increasing or decreasing, we have to look also if it's at traffic stations where we have more of these NOx or NO or NO2 than in the rural background stations. So I mean, for some metrics is increasing, for some other is decreasing. Yeah.
Okay, then one more question is, you mentioned about the monitoring station, the zones and agglomerations. Can you please explain to me what is the ratio of agglomeration and zone? And
the agglomerations are all the urban areas with more than 250,000 inhabitants, or what the countries consider as an agglomeration. I mean, you can, I mean, it's not something fixed, but at least the zones with more than this population are considered as agglomerations.
but is there a kind of a instruction or paper by EEA on how
No,
to?
the directive sets is the directive.
But the directive doesn't really specify what is the nature of an agglomeration. I mean, because you know, we have this agglomeration, for example, in Milan, that it's so wide. I mean, it goes up to the very deep countryside. And
Okay, so you're asking for a maximum limit, because I mean the minimum is this 2,000. Yeah.
Yeah, I mean, when you are planning on zones and agglomeration, what is the difference between zone and agglomeration, and how far can an agglomeration go? What is the ratio behind the idea of making an urban agglomeration?
Well, the idea behind both zones and agglomeration is to identify an area where you can assume that the air quality is similar in terms of dispersion of pollutants, sources, or whatever. So I guess in Milano, if you have like a continuous urban area, this is considered as the same area in terms of this assessment and management, because the authorities, when they created this agglomeration, they considered that it has the same kind of sources, because you have maybe traffic, continuous traffic all around, because of the specification of, I mean, the topology, or how the city is built. So, I mean, if you have a continuous urban area, probably you consider an agglomeration independently of the administrative borders, because these areas are created with this idea of assessing and managing air quality. So it's more than just administrative issues. You have to take into account the dispersion, the sources, and all these things.
Yeah, but how actually, you know, of course, we have a weird situation where you really go into the countryside. So it's not very clear to me if this kind of agglomeration is consistent with the purpose.
The directive also has well, it obliges to review this zonification every 5 years also. So it's, I mean, nothing is like set in stone. So I have created this, and that's also because sometimes sources change, or you can have a city growing. So yeah, it's.
Okay, and one more thing about metals. I was wondering whether you ever thought of kind of highlighting areas in which, I mean, you've done that wonderful job of highlighting that in Italy, and particularly in the Po Valley, we have almost 90% of the population that it's exposed to the exceedancies of 3 pollutants at the same time, which is NO2, PM2.5, and ozone. I was just wondering if you ever thought of doing something similar and not really relating to the exceedances of metals. For example, where in an urban area you have a lot of metals that maybe don't reach the exceedancy level, but are all in the same place. And did you ever?
You mean metals?
Yes, metals, and maybe also
Well,
hydrocarbons.
well, yeah. The thing is, for that we need a speciation of PM 2.5. I mean, we need to know the composition of the particulate matter, not only the. What I presented here, for instance, is the gravimetric method. So what we take into account all the particles, and we weight them. So if we want to have something more specific, we need to go and make analysis of the particles to know, I mean, what is the composition of these particles, because it's true that it's not the same to have salt than to have cadmium.
Exactly.
And of course, I mean, we cannot do this as an agency, and as I said before, we rely on the data provided by the countries also.
Yeah. No,
but it's true that, for instance, when you have to implement a plan, you have to make this source apportionment study to know where your particles come from, because if you just weigh them, you don't know if they come from in industry, if they come from traffic, or if they are natural. So, but this is like more like, I mean, this is a work like has to be done more at the local or regional level. When you want to implement a plan to improve the air quality and you want to implement measures, you have to know which sector you want to address through these measures. So you need this kind of studies.
Okay. And sorry, the last question, when you were mentioning the premature deaths from PM 2.5 and NO2, I know that you are not supposed to overlap 1/3 of, can you explain this to everyone so that we give numbers, we give them correctly?
The thing is, PM and NO2 share sources, mainly traffic. So if we just sum the two numbers, we are double counting the effect. So what the World Health Organization recommends is at least, well, they say that at least there's this 30% of double counting. But it's also true that what we use are the relationship between exposure to one single pollutant and the premature death. It's true that when you are in a city or wherever, you are exposed to several pollutants, and we are not counting the possible synergic or how exposure to several pollutants can make things worse or not. In any case, I always say that, I mean, just counting only if the PM 2.5 effect is serious enough. Like, I mean, we don't need to add the effect of other pollutants. Yes, only with PM 2.5 we have enough. I mean, such an important impact to act that we don't need additional numbers.
Okay, but the 1/3 would be the 1/3 of NO2, or would be the 1/3 of, I mean, if you were to take the data on your page, okay, and we have, on one side we have 14,600 for NO2, and if you look at your slide, and on the other side we have, I don't remember if 50,000 something. If anyone wants to get a total number, which one?
I guess we should reduce 30% of each.
Of each. Okay. Okay.
I need to think about it. But I mean, in any case,
not sure.
as I said, it's we have enough. I mean, an enough big number with PM 2.5. So.
And the last question, I'm sorry, do you have any late data about impact of ozone on vegetation? Like I remember that our environment agency was mentioning some years ago on their report that it caused a 30% decrease of fertility, of growth, of whatever, vegetables or whatever.
Yeah, the reduction on the productivity of crops.
Yeah.
Well, the thing is, this metric we use and is defined in the European legislation. This is AOT. Well, it's a metric that it seems is not so good to calculate the impact, especially in the Mediterranean, because also when, I mean, the Mediterranean vegetation is adapted to this situation, so they close their stomata and they are not so exposed to ozone as in some areas. So there are some other metrics that are now being introduced or have been introduced already in the past to estimate better the effect of the ozone on the vegetation and on the crops. And 2 years ago, we produced a report together with our European Topic Center using this new metric, and I think it was around 20%. I mean, the reduction of the productivity was around 20%. It was for wheat. I mean, the study was made for wheat because also depending on the vegetation and on the crops, you have different effects. But yeah, it was around 20%, if I remember correctly.
And Alberto, we have the last two questions and then we'll leave you to the last part of the presentation. So Jack is asking if the work of Jos Lelyveld and others suggest that agriculture is the leading source category in Europe, with ammonia being the limiting factor in PM 2.5 formation. Do you agree that awareness must be raised on this issue?
Yeah, I mean, I also said in the conclusions that we should act on these sectors that are that have reduced their emissions less, and one of these is agriculture. And it's true that in this cleaner outlook, agriculture was also signaled as one of the sectors that has to reduce its emissions most.
Okay. And then we have the last question, which is, would the EEA support the incorporation of clean air into the Sustainable Development Goals, since it is the most important environmental risk factor?
Well, actually, it's already included in some of the Sustainable Development Goals. Like, it's related to a lot of things. Since I mean, starting for the clean energy, the sustainable cities. So I mean, a lot of we have also I think it was 2 years ago, in the air quality report, we made a small analysis of the Sustainable Development Goals that were related or had something to do with clean air. So yeah, of course.
Okay, thank you very much, Alberto. We had a lot of questions for you. So now, if you want, you can go on with the last bit of the presentation. Thank you.
Yeah. So I will try again to share my screen. Can you see it?
Yes, we can.
Okay, so I mean, I have prepared some slides also on this, but I thought it was more useful to lead you through the web page. there's always a risk when we do this, because normally things start to fail, but I will try to lead you. I don't know if you at some point you will share the presentation, or because I had prepared also the presentation with some hyperlinks so you can easily access all these pages
Yes.
I'm going to
Yes,
show you.
Yes, absolutely.
Okay, well, in any case, I mean, it's very easy. If we go just to the EEA landing page, one of the first topics we see is air pollution. So this is the landing page for this air pollution web page, when we have some highlights, and we can go through several of the products I have used for the in my previous presentation. I have used in the report, but now I would like to focus on this explore air pollution data, because here is that we have a summary of all this data and information. So if we start for the emissions, here we have several viewers, and I will just focus on this one, which is, I introduced at the beginning of my presentation the European National Emission Ceilings Directive, setting this maximum amount of concentrate of pollutants that can be released into the atmosphere, and also the Convention on Long-Range Transboundary Air Pollution that has something similar, which is called the Gothenburg Protocol. So if we go here, we can see we have a viewer when we can visualize this amount of emissions released into the atmosphere. I will try to lead you through it. Here we have the aggregation. We are looking. We will see that we have also the information at country level. We can select the pollutants, and you see here we have a lot of pollutants. We have also these PAHs and some of the dioxins, furans. I mean, so these pollutants have to be reported in the national emissions inventories. And we have also here these sectors I was presenting, the economic sectors I was presenting at the beginning. We have this information for several years, and we have also the information at, at national level. So you see here that we have the series. This, maybe ammonia is not the best one, because ammonia is mainly agriculture and is very highly. So here, for instance, we have for NOx for Italy, the series of emissions from 1990 to 2017 with the different sectors. We have also here the download data, where again, we can select an aggregation or a specific country. We can select the pollutants. We can select, in this case, it's the national total, but we can select also the specific sectors. And then we just download the data. So this is, for instance, what I have used in my presentation to present the data for 2017 for Italy. So this one for emissions. If we go to the concentrations, I didn't say at the beginning of my talk, but we have two kinds of air quality data reported by member countries. We have data reported on an annual basis, and these are the ones that the Commission uses to check compliance with the standards set in the directive. And these are what we call the air quality statistics. So here we have for the main pollutants, those who have legal standards for several years, several pollutants, and then also several statistics, because I didn't go in detail with this, but we have some of these legal standards are related to long-term exposure. So we have annual limit value, for instance. Some other are related to short-term exposure as a daily or hourly limit value. So these statistics also, when Anna asked me about ozone, I was talking about different metrics. So these things can be chosen here also. We can select whatever country. We can also select by kind of a station if we want to focus on what's the effect of traffic, for instance. And this is more or less the same map that I was presenting before, the one that we present in the air quality report. Again, we have for each of the dot, it represents one station, and clicking on the station, we have a specific information for this station. So this is and as I said, we have different years, and this is the information that the European Commission uses every year to check compliance with the legal standards. But the countries also report information on an hourly basis or daily basis, and this is what we call the up-to-date data. So this is near real-time data. And here we have not so many pollutants as for the annual data. You have to take into account that these data have to be measured in automatic samples because otherwise they cannot be reported on this hourly basis. And these are presented up to, back to 15 days. And this is especially important, for instance, when in summer, if we go to ozone, we can easily see if we have an episode because we can see hourly how the concentrations are increasing or decreasing. Or for instance, when we have particulate matter, sometimes we can see very clearly when we have dust coming from the Sahara. So we can see also how the concentrations are increasing according to this influence of the natural sources. And of course, also these hourly data are used in the air quality index, which is a way of presenting this information in all this information for several pollutants in a more compact way. The thing is that today the air quality index is not working. So as I said, sometimes this happens. And I don't know why, because I just discovered this issue today. So I contacted my IT colleagues. You also know that now we are working from home, so I don't know if how fast they will be able to solve this. The good thing of all this is that we can also download all this data. So if we want to make a specific study, a specific analysis, we have, because what we present in the viewers, as I said, for instance, in the annual viewer, is an aggregation. If we need the raw data because we want to make our own analysis, we have this page where we can download the data and work with them. So we have also here some tables when we have some specific information reported by the countries. So I wouldn't go in detail here because it's like a very detailed information, and it's like more than just concentrations or more than just where the station is placed. But here, one of the main things is what we call this data flow J, because here is where the countries declare if there has been an exceedance or not for each of the zones and for each of the pollutants. So here we have several filters also. We can select our country, we can select the year we want to look at, the pollutant, which kind of a standard, what is called protection target, sorry. We want to check the limit value. We want to see in the cases where we had an exceedance, And then we here have the list for all the territories and all the years. So let's go 2017 and Italy. So these are the 69 zones where we had an exceedance of the limit value of PM10 in 2017. So this is another viewer that can be useful for a more detailed analysis than just looking into the stations.
Alberto, can I
Yeah.
ask you something? Can we make an attempt of finding out where exactly that 3 million Italians who live subjected to 3 exceedances of 3 different pollutants live?
Well, we have to go and search for the. I mean, because here we will have the zones exceeding. Well, you didn't want PM10, you wanted PM2.5. But you see, we can only select pollutant by pollutant. So we could get the here we get the 13 zones where PM2.5 was exceeded. We can do the same for NO2 and we can do the same for ozone, and then
okay.
we could merge them.
Okay, I got it. I got it. So that's interesting.
Yeah.
I think Fabio is our very technical person. I hope he's he's listening.
Okay, you can tell him otherwise. So, and coming back to this page, when we have all the information, we have gone through the emissions, the concentrations, these tables. We have also a section when we can access all the reports related to air pollution, and of course you will have the air quality report I was presenting before. We have also all the indicators, and in this case, for instance, you have this when we calculate the percentage of urban population living in areas where the legal standards are exceeded. So this is the same graph I was presenting with these these figures, but in this case we have data from 2000, so you can see the evolution again at European Union aggregation of the population living in cities where either the European standards or the World Health Organization guidelines were exceeded. And finally, we have the same as kind of summary at country level. So if we go to Italy, we can see here a summary of what I was showing. So this is the graph I showed to you with the urban population in Italy living above the legal standards for these 5 pollutants. You have also the evolution in the last 5 years. You have the premature deaths as calculated in the report and presented here. I mean the totals and also the Italian case. You have the situation I was presenting in the maps for all Europe. Here you can select it for 5 pollutants. You have again information on every station, clicking on them, and we present also the average of all stations. So we can see that even as Elisabetta was saying, Italy is exceeding at some point almost all the standards. We can also see here that on average and throughout the years, the situation has been improving. We can see here the case of NO2. This is the average of all the stations. You can see here how the stations are described by traffic, background, urbans, and so on. And finally, you can also see some information on the emissions. So here again, well, we have here the ceiling set by the European directive. You have here the total emissions. You have here the emissions by the different sectors, and you have here the different pollutants. So this is also like, I mean, a nice summary per country where you can go for a specific information. And with this, I will conclude this section. I know I've been a bit fast in this part, but I mean, if you go to this page and you play with all these tabs, you can find the information I presented. And of course, if you have some doubts, you can always write to us in the agency, and we will try to solve any question or any doubt.
Thank you so much, Alberto. It was so interesting. And of course, we also have the recording, so we will publish it on our website so that if people want to go and have a look at it, they can, so no worries. I only have one last question for you, which I have read just now on Facebook, which comes from Victor Valverde, and he is from the European Commission, and he will be our host in our next webinar on Thursday. So I will read you his question, and he says, I was wondering what are the implications of COVID-19 pandemic and lockdowns in many European countries for the historic analysis of emissions and air quality in Europe. Is there any specific project in the EEA that will collect the data from this period? Thanks.
Yeah, well,
yeah, actually, you have that lovely page.
Yeah. I will present
it now. It's
now.
not very clear. I cannot see it very well. I don't know why. Maybe you can open and show it to us, because it's very interesting. But
I will. I mean, the thing is, I mean, since the very beginning of the lockdown, we thought that, of course, I mean, we were aware that there was a reduction of emissions. We are not working currently on the emissions because, I mean, all these data we present are the estimation of countries and are done at the annual level. So we have to wait until they collect all the information for this year to see if we can, what we can see in the national emission inventories. But we know for sure that there has been a decrease in the emissions. You are witnesses of this for sure in Milano. And what we have, and now I need to again share my screen. I mean, of course, we have been receiving this hourly data. The data I was presenting to you, and we have created this viewer when trying to analyze the impact of the lockdown. We have created averages at city level for NO2 and the 2 p.m. So I don't know, Anna, what you cannot see, but let's see. I will try to show you two cities that I always use as an example, which are Bergamo and Milano, because we can see very clearly the impact of the lockdown measures. So what we have done, as I said, is we have aggregated all the data at city level, and we have calculated weekly averages. We have done this to consider the variation during the day and the variation during the days of the week. But of course, we haven't taken into account the effect of meteorology. And this is very important because, I mean, of course, concentrations have decreased because there has been a decrease in the emissions, but the effect of meteorology, either increasing or decreasing concentrations, has not been taken into account here. So what we have here is, in the first graph, we have like this representation by dots of the weekly concentrations, and we have here a table. So if we go to the beginning of the lockdown that in Lombardy was on the 24th of February, we can see this is the average concentration, as you can see, on that, I mean, on the week starting on this day, so the week starting on the 24th of February. And here we can see the reduction in comparison with the previous week. So we can see that along the lockdown, we saw reductions of the concentrations until the minimum that was reached on the week starting on the 27th of April. And since then, we have seen more or less an increase of the concentration. So as I said, here we have the case for Bergamo and Milano. In the case of Bergamo, we reached this minimum of 11 micrograms per cubic meter. And in the case of Milano, it was 15. You see that in some cases, we came from values as high as 60. In any case, these are, as I said, these are weekly averages. These weekly values are not related to any legal value, because for instance, for NO2, we have hourly limit values and annual limit values. But this is a way of illustrating the variation and the decrease of the concentrations due to COVID-19. And coming back to the question in Facebook, of course, I mean, we will try to make a more in-depth analysis and take into account the meteorological variability, and we will present a specific chapter in this year air quality report. And as I said, to see the impact on the emissions, we will have to wait.
Okay, I see. Thank you so much for the reply. So I think we are done.
I have a question.
Of course, Anna.
Yes. On the air quality index, can we see all the Italian data now or not? I don't believe so.
Well, the thing is,
no, apart from today, but
no. Yeah, for PM, the thing is, the Italian data are measured using the reference method in most of the cases, and this means daily values. So the data we show in the air quality index are based on hourly values, while most of the Italian stations are reporting daily values, not hourly values.
But why is everybody else also reporting hourly? I mean, I'm sure that all the other nations are measuring daily values with gravimetric, but why do they also manage to provide
the thing with
hourly data?
Yeah, the thing with particulate matter is that the reference method, that is the method recommended by the directive, is gravimetric, and then it's daily values. So if you want to measure particulate matter hourly, you have automatic samplers, but then you have to demonstrate that your sampling, that your sampler is equivalent to the reference method. So I mean, it's not that Italy is doing wrongly measuring daily values, also because the reference, I mean, the limit value is the daily limit value, why they don't report, or why don't they measure also hourly? I don't know. I mean, that's a question of how your network is defined. The thing is, if you are measuring hourly value, you are not using the reference method, and you have to make some studies to prove that this method is equivalent to the reference method recommended by the directive.
What do the other countries do? Like France or England or Germany?
Most of the countries have both gravimetric and automatic samplers. And then they report the automatic measurements on an hourly basis. In any case, we are also working on a daily UTD viewer. So this viewer is showing the hourly values. We are working on a daily one. So we will show the data for Italy, the PM data for Italy.
Okay, but then, but the current data on the air quality index is like real time, like, I mean, wherever you see it, it's real time, so you receive it.
We have a delay of 2-3 hours.
Wow.
But it's the same we see in the UTD data viewer.